Hello students, I hope you are all good. In this lecture, we are discussing our next chapter of physics, that is motion in a straight line. This chapter is about to be very interesting, so pick up your pen and copy and get ready for this interesting journey. So let's start our journey. Some interesting questions arises in our mind. How long will it take to space probe to travel to Mars? Second is that where will a football land if thrown at a certain angle? This chapter gives the answer of these questions. After that, let's talk about motion. Motion is common to everything in the universe. We walk, run and ride a bicycle. Even when we are sleeping, air moves into and out of our lungs and blood flows in arteries and veins. We see leaves falling from trees and water flowing down a dam. Automobiles and planes carry people from one place to other. It might only be a small amount of movement and very slow, but movement does happen. Even if you appear to be standing still, the earth is moving around the sun and the sun itself is in motion in the Milky Way galaxy, which is again moving within its local group of galaxies. The concept of motion is a relative one, and a body that may be in motion relative to one reference system may be at rest relative to another. Let's understand this by an example. Two people are sitting in a car, says A and B, and the car is moving on the road. Another man, capital C, was standing on the road. If I ask C that the person A and B are moving or not, then C will say A and B are moving. But if I ask B that the person A is moving or at rest, then B will say A is at rest. After that, moving ahead, there are two branches in physics that examine the motion of an object. First, kinematics, second, dynamics. Let's talk about kinematics. Kinematics, it describes the motion of an object without looking at the cause of the motion, that is force. The word kinematics comes from a Greek word kinesis, meaning motion. The study of kinematics can be abstracted into purely mathematical expressions which can be used to calculate various aspects of motion such as velocity, acceleration, displacement, time and trajectory. Kinematics is used in astrophysics to describe the motion of celestial bodies and systems, and in mechanical engineering, robotics and biomechanics to describe the motion of systems composed of joint parts such as an engine, a robotic arm, or skeleton of human body. After that, let's discuss second branch, that is dynamics. It relates the motion of objects to the forces which cause them. The foundation of dynamics were laid at the end of 16th century by Galileo Galilei, who by experimenting with a smooth ball rolling down an inclined plane derived the law of motion for falling bodies. He was the first to recognize that force is the cause of change in velocity of a body, a fact formulated by Isaac Newton in 17th century in the second law of motion. This law states that the force acting on a body is equal to the rate of change of the body's momentum. After that, let's discuss reference frame. In order to describe an object's motion, you need to specify its position where it is at any particular time related to a convenient reference frame. Earth is often used as a reference frame and we often describe the position to or from Earth.